Let's now try to design a simple Turing machine for a given language. Let's say that our language is as follows: 0 to the n, 1 to the n, such that n is greater than or equal to 1. Our alphabet simply consists of zeros and ones, and we want n zeros followed by n ones to accept a given input string, and for all other strings we will reject them. Thus we will basically design a decider for this language. Let's first try to think of what our Turing machine should informally do in order to be able to decide such strings. So if we have 3 zeros followed by 3 ones, for instance, our Turing machine should go to the accept state. But on the other hand, if there are 3 zeros followed by 2 ones, our Turing machine, for instance, should go to the rejecting state. Okay. So remember that we can write new symbols on the under the tape head as we go along in our computations, and we can move the tape head left or right whenever we want to. So informally, what we will try to do is, let's say we are given 0, 0, 0, 1, 1, 1, and the rest of the tape is just empty symbols. Iteratively, we will try to do the following. Initially, we start out at the leftmost position of our input. Iteratively, we will do the following. Mark as 0. So let's say we mark it with a dot. Mark as 0. Keep on moving right until you find a 1 corresponding to the 0 that you have just marked, and mark that 1. Okay, and now go all the way to the left until you find the first unmarked 0. Let's say this one, and repeat the same thing. Mark that 0, move right until you find a 1 corresponding to it, mark it. Move left, find an unmarked 0, mark it, and move right until you find an unmarked 1 and mark it corresponding to the 0 that you have just marked. So we basically will try to, corresponding to every 0 that we see, we will mark a 1. So this initial 1 is marked due to this initial 0. The second one is going to be marked due to the second 0. The third one will be marked due to the third 0 that we have marked. At the end, we won't find any zeros that are not marked. In that case, we will keep on moving right until we finish all the marked ones. And at the end, if we encounter a blank symbol, we will know that the number of zeros that we have marked are the same as the number of ones. Informally, this is what our Turing machine should do. To formalize this idea, we will try to give the state transition diagram of our Turing machine. Our initial state is Q0, the starting state. At the starting state, since n is greater than or equal to 1, we expect at least 1 0. So initially, you'll have all 0, 0, 1, 1, 1, and the blanks. We will have the 0. What we will want to do is mark that 0 with a new symbol, 0 dot, meaning that we have seen this 0 and we will try to match a 1 corresponding to it and mark that 1 to say that it has been matched with an existing 0. So we should first mark the initial 0 that we see with the following transition. This says that if you see a 0, this initial 0, replace that 0 with a new symbol 0 dot. 0 dot is now in the first symbol in our tape, and make a right move. After the right move, we will be on our tape head will be on top of the second symbol 0. Okay. Now, it could be the case that our initial symbol is not a 0 but a 1. If it is a 1, we should reject it because we want at least and since n is greater than or equal to 1, we want at least 1 0. So if we encounter a 1 at q0, a 1 at q0, let's say 1 goes to 1 and r, we will immediately go to our rejecting state q reject. Okay. Now we have, let's get back to q1. We have marked our first 0 with a 0 dot. Now we should skip all the zeros that we see further to the right until we find our unmarked 1 that we will mark corresponding to this 0. So we can make a loop in here on q1 if we keep on seeing, to be able to skip all the zeros that we see. So 0 0 r. This says that if you see this 0, just replace it with again the same symbol 0 and make a right move. So the tape head is now here. If you see a 0, then again replace it with the same symbol 0 and make a right move, and now the tape head is on the symbol 1. So once we get to the symbol 1, we need to mark that 1 with a special symbol. Let's say we need to replace it with a 1 dot corresponding to the fact that now we have found a 1 corresponding to the 0 that we had just marked. So at q1, if once we encounter the symbol 1, we will replace it with the symbol 1 dot, meaning that this 1 corresponds to the 0 that we have just marked. And now we can make a left move rather than a right move, because now we will need to keep moving all the way to the left until the first dotted symbol that we find, so that now we can mark the next 0 and a 1 corresponding to it. So make a left move, go to a new state, q2. So at this point we are now on top of this 0, the last 0. Now we should keep on moving left until we encounter 0 dots, the rightmost marked 0. So in here we will, if we encounter 0, replace it again with 0 and make a left move, okay, until we encounter the 0 dot. What should we do when we encounter 0 dot? Now we are close to our initial starting configuration. This first 0 has a symbol 1 corresponding to it. Now we should do the same check for the next 0. Mark it and find a 1 to mark corresponding to it and do the same thing. So this means that we can now repeat this operation within a loop. Okay, so within a loop, what we will do is now once we encounter the 0 dot, don't replace it with anything else. Replace it with 0 dot and make a right move. This will take the tape head to the first unmarked 0. And now we do the same thing. If you see that 0, mark that 0 with a 0 dot and go to a new state. In here, skip all the zeros with this loop. So this 0 will be skipped. Okay. Now, what we are in search of is a symbol 1 that is unmarked, so that we can mark it corresponding to the 0 that we have just marked. So what should we do once we encounter this marked 1? We should skip that as well. So we can add that as a transition within this loop. So if you encounter a 1 dot, skip those 1 dot as well. So if you see a 1 dot, replace it with a 1 dot and move right. So with this loop, we will skip this 0, we will skip this 1 dot, and now our tape head will be on top of this second symbol 1. Now we need to mark it. We can mark it with this transition, and now we have these 2 zeros marked, these 2 1s are marked. We are at state q2, and after this transition we have made a left move, so our tape head is on this first marked 1. Again, now we do the same thing, go all the way to the left. So if you keep on encountering zeros, But now again we need to add yet another condition as well in here, because it could be the case that we encounter one dots as well. Even if we see a one dot, make a left move. So make a left move within a loop so that you skip them, and once we encounter our rightmost 0 dot, we will go back to the beginning. So this is our main loop. This part corresponds to our main loop, where we mark a 0, move all the way to the right until we find an unmarked 1, mark it, and now move all the way to the left until the rightmost 0 dot to find the next unmarked 0, and mark it, corresponding to it, mark a 1 and go back. So this is the main loop, where iteratively we keep on marking a 0, finding a symbol 1 to the right of the tape that is not marked, corresponding to it, mark it, and go again to find out a 0 that is unmarked. This is our main loop. And if at some point, once this main loop finishes, let's just keep on simulating on this input string. We will be at Q0, we will mark this 0 with 0 dots, go to Q1, we will skip all the 1 dots, get to this unmarked 1, take this transition, mark this 1, and then move left. We'll keep on moving left until we encounter this 0 dot and go back to Q0. At this point, now we don't have any marked zeros on our tape. Okay, so we have seen 0 dot, we have made a right move, now we encountered a 1 dot because our zeros are all marked. So we need to make a new transition for this, because out of Q0 we need to have a transition that tells us what to do once we encounter a 1 dot. Once we encounter a 1 dot in terms of our input string, the meaning is that all zeros are marked corresponding to ones that we have to the right of the input tape. Now, if you see a 1 dot, replace that 1 dot with yet another 1 dot. Don't change the symbol, make a right move. So basically, if you were on top of this first 1 dot, our tape head will move on to the second 1 dot. Now we cannot stay just in here, because now we need to see that all the ones that follow are already marked. To do this, we have a loop that says if you keep on seeing a 1 dot, replace it with a 1 dot and move right. This way, with this loop, we will check that all the ones, all the symbol ones that lie to the right are all marked, which means that there are zeros corresponding to them to the left of the input. And at the end, if we encounter our blank symbol, then we can go to the accept state. Blank symbol in the input, just replace it with again blank symbol, make a left or right move, but go to the accepting state, Q accept. Notice that, so since this is what we have designed is a deterministic machine, and as usual with the deterministic finite automata, similar to the finite state automata, we need to be able to provide a transition out of every state for every input symbol that is possible. This is the main idea. So we have basically written down all the transitions that we should be taking when we need to accept the given input string. For all the rest of the missing transitions, we should take them to the rejecting state, Q reject. Okay, so for instance in here, for this transition from Q0, we have a transition on seeing a symbol 0, we have a transition on seeing a symbol 1, we have a transition on seeing a symbol 1 dot, but we don't have, for instance, we haven't created yet a transition for seeing the symbol, for instance, the blank symbol. What should our machine do when it encounters a blank symbol when it's at Q0? Okay. For this, we need to be able to check the meaning of seeing a blank symbol at this point. Okay, so a blank symbol in here means that we have just encountered our last our rightmost 0 dot, and right next to our 0 dot we simply have a blank symbol. Okay, but this should not happen if we have 0 to the n, 1 to the n, where n is greater than or equal to 1. So in this case we can simply go to the rejecting state, and we need to write this down for all other. So we can write it simply as, for all other input symbols go to the rejecting state, such as these ones. If you encounter a 1, go to the reject state. If you encounter a blank symbol, go to the reject state. Or if you encounter a 0 dot, do the same thing. We can repeat this for Q1 as well. If at Q1, if we don't encounter a 1 or 0 or 1 dot, for anything else, we can just go to the reject state. For all other symbols, go to the rejecting state. For instance, if you encounter such as these ones, such as if we encounter a blank symbol, we can immediately go to the rejecting state with the following transition. This tells us that if you're at Q1, if you encounter a blank symbol, then we can immediately go to the rejecting state in our finite control, and the Turing machine will reject the given input string. How can we have a blank symbol? How can we encounter a blank symbol when we are at Q1? Let's say if we have a single 0 and nothing else, 0 followed by all blanks, then we will mark for our first symbol 0, but then we won't be able to encounter a 1 corresponding to that 0. We will simply encounter a blank symbol, which means that we need to reject that state. We can do the same thing for all the rest of the transitions. So for all other symbols, simply go to the reject state. For all other symbols, at Q2, for all other symbols, simply go to the reject state as well. Let's see how this machine behaves on given sample input strings. We should be able to see how it already works on an input string that should be accepted, basically n zeros followed by n ones. So let's try to see how the machine works on an input string that it is supposed to reject. So let's say if we have 0 0 followed by 0 0 0 followed by 2 ones, and the rest is just blanks. Our machine should normally reject this input string because we have 3 zeros followed by 2 ones. Initially we start at Q0, and our tape head is on the first 0, on the first symbol 0. With this transition we replace that 0 with a 0 dot, and now we are at Q1. At Q1 it says skip all the zeros, so tape head is here, it will go on to the next 0, and then it will go on to the next symbol. Through this transition, 0, if you see a 0, replace it with 0 and move right. Now at Q1, we are at Q1 and our tape head is on the symbol 1. This transition tells us to mark that symbol with a 1 dot, because we are marking this 1 dot corresponding to the 0 that we have just marked, and go to Q2 by making a left move. So now our tape head is at this 0 on top of this last 0, and we are at Q2. It tells us the following: if you see 0, make a left move. So we'll make a left move. Again, the same thing. If you see a 0, make a left move. You made a left move, and now we are on top of 0 dot. If you see a 0 dot, replace the 0 dot with again 0 dot. Don't change it. Make a right move. Now our tape head is on top of the second 0, and go to the beginning state Q0. Now we have finished one iteration of marking a 0 and marking a 1 corresponding to it, and we are at our initial starting state Q0, and we will repeat the same operation. Mark 0, go to this new state, skip all the zeros, skip all the 1 dots. This is the second transition. That's what it says. If you see a 1 dot, again replace it with 1 dot, simply make a right move. Finally we are on top of this unmarked 1, mark it with a 1 dot, make a left move. We are now on top of this first 1 dot and go to Q2. And in here it says move all the way to the left until you encounter a 0 dot. Once you encounter a 0 dot, you are at Q0. Which tells us to, if you see a 0, so this is our next, this is our tape head is currently on the last 0. It says replace 0 with 0 dot, so mark this 0 now at Q1. Our goal will, the goal of the machine will now be to find out a symbol 1 that is not marked, so that it will mark corresponding to the 0. So it will skip all the 1 dots, and once we skip all the 1 dots we make right moves, at the end we will our tape head will be on top of this first blank symbol. So we haven't been able to take this transition because we haven't encountered a symbol 1. Rather, we have encountered our tape head is on top of a blank symbol, so that we will take this transition because we see a blank symbol in our under the tape head, and we'll go to the reject state. Why? Because we have marked a 0 and we haven't found a symbol 1 to mark corresponding to that 0. Okay, so our machine will go to the reject state. We can do a similar simulation on the following string. Let's say 0 0 1 1 1 and blanks. Again, our machine should reject this because this string contains 2 zeros followed by 3 ones. So we start out at Q0 and our tape head is on top of the first symbol. We take the first transition, mark this initial 0, skip the 0 and find out the first unmarked 1. Take this transition, mark that 1, make a left move. Now our tape head is on the second 0 and we are at Q2. Again, make a left move. We made a left move, and now under the tape head we have a 0 dot. Since there's a 0 dot, we will take this transition. Don't change 0 dot, just make a right move. Now our tape head is on the second 0 and we are at Q0. This says take this transition, change the 0 into 0 dot, and then skip 1 dots by making right move. Skip this 1 dot, and now our tape head will be on top of 1 and we are at Q1. Mark that 1 and take this transition and make a left move. So now we are on top of the first dotted 1. And it says skip dotted ones, go to the left. Once you encounter a 0 dot, take this transition and make a right move. Now our tape head will be on top of the first 1 dot symbol and we are at Q0. At this point we cannot take this transition because under the tape head we have a 1 dot. Since we have a 1 dot, we will move on to this state where we will check whether all the ones are marked or not. So 1 dot, if you see a 1 dot, make a right move. So now our tape head will be on top of the second 1 dot symbol. We will take this looping transition, so make yet another right move. Now our tape head will be on the first undotted 1. At this point we have to take this transition because we can only take the transition if we see a blank symbol and go to the accept state. For all other symbols, we simply go to the reject state. So once we encounter this symbol 1 at this state, let's give the state name Q3, we go to the rejecting state because we have encountered a symbol 1 that doesn't have a corresponding 0 in the input string. So that's why we go to the rejecting state. You can actually, as an exercise, try to simulate how this Turing machine behaves on other sample strings as well. You should be able to recognize that we can extend this Turing machine actually to, we can extend this Turing machine to decide a more general language, 0 to the n, 1 to the n, 2 to the n. How? We could just add yet another state in here so that the idea would be similar. Mark a 0 and then move all the way to the right to find an unmarked one, mark it corresponding to the 0 that is just marked. Again, move all the way to the right to find a 2 that is not marked, mark it. And then go all the way to the beginning and repeat the same thing. So our repeating loop will almost be the same, except that we will have yet another state where we move towards the part of the string where we have 2's, and we mark a 2 corresponding to a symbol 1 that we have just marked. So we can extend the idea to decide such a language as well. The importance of this language is that, remember that we had seen that this language is not context free. Okay? But we have just seen that this language, although it's not context free, it is Turing machine decidable. So we can design a Turing machine that will decide this given language. So this implies that the Turing machine model is actually more powerful than the push-down automata model, than the previous machine models that we have considered so far.